Welcome. This video is intended to help you get started on the Origin of Magma worksheet. If you haven't yet pulled up the worksheet, pause this video and access the worksheet now. Before we jump into the assignment, let's take a closer look at the simplified pressure temperature diagram, or PT diagram, that you'll be dealing with. Here we can see what that looks like. The top axis is temperature. Low temperatures on the left, and then temperature gets higher and higher and higher as you move in this direction. The y-axis is pressure, which is synonymous with depth in this context. So here we have higher and higher pressures, which correspond to deeper and deeper depths. The line here represents the specific pressure temperature conditions at which a rock melts. On one side, we have the PT conditions at which magma or melted rock would be created. And on the other side of the line, we have the pressure temperature conditions that would result in solid rock. Now the line itself, right? This represents the exact pressure temperature conditions that would result in melting, or conversely, if you were already a melt and you cooled down to this point, then that would result in solidification. Keeping all of this in mind, we should now be ready to start the assignment. The directions ask us to draw arrows on simplified pressure temperature diagrams according to the scenarios below. We are also told to be sure to start your arrow at the red dot and draw it in the direction the dot would move in each scenario. Scenario 1 here refers to diagram 1, this diagram here, and states that an area of solid rock in the subsurface is heated quickly in place and starts to melt. Indicate the direction the dot would move in pressure temperature space. Okay, well, if this little bit of rock, a rock located at this depth, is heated quickly, then the temperature of the rock must be increasing, so the temperature is going to move in that direction. However, because it's staying in the same place, depth won't change at all, and if depth isn't changing, then obviously the pressure won't be able to change either. To draw in an arrow representing this situation, I'm going to start at the dot as instructed and then draw like this. So we have a rock, its temperature is increasing until it gets right there, it melts. So the arrow should look like this, right? So here we have the arrow representing an increase in temperature with no change in depth. That's why the arrow is horizontal. It represents the fact that this rock doesn't move up or down. It just increases in temperature until it melts. The melting happens as soon as it crosses this solid liquid line, okay? This situation describes melting rock via the addition of heat. Let's go ahead and do one more together. Scenario 2 states that an area of solid rock undergoes increases in pressure and temperature as it is buried in the subsurface, following parallel to the liquid-solid line for this exercise. Indicate the direction the dot would move in PT space. Okay, this time our little dot of rock experiences both an increase in depth and an increase in pressure. An arrow describing this in PT space would look like this, okay? So as we go deeper into the earth and the pressure increases, the temperature also increases, and all of that happens parallel to the liquid solid line. In this case, it looks like no melting is going to occur. All right, hopefully you've now got a strong start to the assignment. Go ahead and try the rest on your own. This concludes the Origin of Magma assignment help.